Thanks everyone for participating in this session, which is hosted by Skilling on job opportunities. And thanks for sparing your time on a Saturday evening. Uh, with, Along with you all, I welcome Mr. Shinto. So for accepting this and for coming forward to participate in this session. So Mr. Shinto is the Director of Southeast Asia Operations in LDRA Technology, and he's a very influential leader as well as an entrepreneur for over 25 years of experience in the industry. He has been handling um, many embedded software, safety critical, mission critical applications for over past 17 years, and he has been an active member in many government bodies, academia, and professional organization. And Shinto is a good friend of us, and he's there to answer all us questions today that we have on safety critical embedded software and why this is very important when it comes to embedded aspirants. So we have so many things to discuss with them. As you, I'm also equally excited in this discussion with Shinto. Hi Shinto, over to you.
Appreciate you guys inviting me. The subject is very close to my heart. If you ask me, I started day one in this area where hardly any programs used to talk this language except in some nuclear centers or even some aerospace programs, space programs. That's it. But today, you look around anywhere, you see people talking about safety security. We will probably see that why this shift that has happened. Looking at the nature of the audience, I believe many may not know what is embedded itself. So we will start off that itself. What do you mean by embedded? What do you mean by safety? Why this so-called shift that is happening in our society, what drives these changes, and what opportunity exists for us. And then if you know what all those opportunities, how to grab those opportunities, the next one. So I hate using slides, but however, to explain the basic concept, next 15 minutes or so, I will run through a couple of slides. Now, whether you are from circuit branch or doesn't matter. This session, I will make it in a way where even anybody can understand. So that doesn't matter. So this is a topic. Just one slide I will talk about. Where are we from? We are from Liverpool. Last 46 years, we've been in this business. Whenever people talk about software safety or security, this is the first name today people talk about because we work with the world's largest aircrafts, like from the 380 to the largest nuclear programs to fighter programs. Wherever safety security is there, you will find us. And to be frank, it is an academic offshoot from Liverpool University. So whatever we do, even this program, one of the connect I have is I spend a lot of time in skilling related activities. I sit on the board of several universities. I also drive our global university program within LDRA because of passion towards this area. With this understanding, let me take you to the history. Now, when I joined engineering in 1990, as I told you, 99% of the processes, even more than 99% of the processes getting shipped in the world used to go to PC world. Now, any idea after 32 years, what is the percentage of processes going to PC world today? Wild guess is less than 1%. Now, that's where the shift that's happened in our society. Why that has happened? The first point is the concept called pervasive computing. What is pervasive computing? Pervasive computing means computing for anyone, anytime, anywhere, not restricted to a machine on a desktop, on a laptop. No, wherever you go, you see computing. That is pervasive computing. Why? People wanted increased efficiency for whatever you're doing. It could be your washing machine, your car, your medical device, your gaming machines, whatever you do. That's where actually people started putting computing into those devices. Now, what really drove the demand for this sector? One is people wanted intelligence because of efficiency factors. The most important factor is the connectivity. Earlier, it was wired connectivity. Today, nobody talks about wired. It's all about wireless. The wireless connectivity was the main shifting factor in this game. You talk only about normally mobile phones, right? It's only a small fraction of this game we are talking today. Anything and everything. Your car seat to your music systems to your washing machines, anything and everything. At home, whatever your remote. There's nothing in this world where you don't find an embedded computing device attached to it. Today, I don't know whether you noticed 2 weeks back or last month, Elon Musk announced chips that can trigger your neurons in your brain, right? That means you can put a chip in your brain and start controlling the behavior of your brain, whether it's good or bad, but it has got a huge medical application. Now, the next one is semiconductor industry. As I told you, the chip industry has completely shifted towards the embedded field. And during this field transition, what has happened is people wanted complex functionality. So what happened? The semiconductor industry became so complex. Today, we are not talking about the limitations of Moore's law. You can have multi-core. Nothing stops you from increasing power on your devices, computing power I'm talking about. Even if you have heat issues, you will overcome that. That's the technology that has come. The hardware industry has grown like anything. What about the software industry in this game, especially the embedded software? The size of the software has grown like anything, like an elephant. Now, whenever software grows like anything, it also brings in safety security issues. Now, guys, that is where we company like LDRA survives. People want more functionality, more software on your devices. We'll see a couple of use cases, what's happening in the industry today, particularly automotive industry. I'll take an example and show you what has kind of change that has happened in the industry. Let me take you automotive industry that will happen. I call it 360-degree digitization. When I say 360-degree digitization, the complete car is getting digitized, one aspect, but the design, development, testing, including the crash testing of your car can be digitized. It can be done in a simulated world. The complete life cycle of design, development, testing can be done through a digital twin platform. That's a world which we are living in. We call it, the software-defined cars. Now, when you go like that, this is the current trend right now. We call it PACE, personalized, autonomous, connected, and electric, where the embedded software running in your car drives this transition. Even if it's an electric car, you will find the number of lines of code in these modern cars is more than the world's largest civil aircraft, Airbus 380. My customer will be. This has happened in the last couple of years itself. So as you go forward, this is going to drive, where even if you want to personalize your car experience when you are driving, again, software is going to play a major role. So more and more software. And let me take you the next side of the game. First, world's most expensive car crash. This happened in a highway in Japan. Any idea? We're talking about, more than 10 cars hitting at the same time. Look at the shape, the accident site. Any idea how many people died? None. That's what we call about safety is all about. Safety comes by design. Another aspect from a safety angle, years back, Boeing Dreamliner, the new aircraft which they launched, was grounded basically on safety ground. What does it mean? Boeing lost billions. So safety can kill your brand. Safety can cause financial losses. Safety can create deaths if not managed properly. So it also comes after roti kapda makan, right? The food, shelters, safe. That is the first thing. The Indian context, we call it the basic necessity of human beings is food, shelter, clothing. After that, only the safety security comes in. So we as a country, if you take, or most of the countries in the world, we are past to that basic things. Today, we are in a level where economically we can afford better, safe, and secure systems. Now, let me give you a basic definition of what is safety and what is functional safety. Safety is nothing but it is an acceptable risk that you can take if something goes wrong. For example, if your car hits an accident, it happened. But how far you can accept a damage or an injury? That's the definition of safety. Now, you might ask me, what is the difference between the overall car safety, which people are talking about, 5-star car safety rating, where, the Indian car manufacturers, particularly in India, you can see the Mahindras and Tatas, just on the safety ground, they've beaten the rest of the foreign players. So overall, car safety game is a different exercise where you perceive, subject the car to a crash test and rate it in a level of an agency called NCAP, which does that. And what is the functional safety? Functional safety goes to each subsystem. It could be a braking unit, it could be your airbag unit, it could be anything. What in your car? At that, each functional unit, you test it and you clear it for a functional safety framework. We'll go a little more deeper on that subject for you to get an idea. Now, there is another aspect. We talk about safety and security. Look at two cars. Car which belongs to several decades back, a car which belongs to the last decade, which had a little more software content in that. The first car, is it safe? No, but it's secure because not enough software was there for people to hack. So what does it mean? The more the software component in your car, on your medical device, in your aircraft, anything, your attack area is increasing. right? So you are inviting security issues, even though you are adding safety parameters to your devices. It is, such a dichotomy. So that means, when you are designing a system, you need to be aware that, by loading more software and electronics, you're also probably inviting another trouble, the security factor. Now, as I told you, safety and security are two sides of the same coin. Just by making your car safe doesn't mean that you are safe forever. You need to look at the security aspect also. You go to YouTube, you will find the Jeep hacking story. How on a highway somebody could remotely hack a Jeep car and making your life miserable. In fact, even in India, I've been discussing with the government of India, where government is really worried how to prevent a car lying on the road. Somebody can remotely start it and take it as a terror weapon on the road. That's the world which we are living in. So these two aspects are the one which will drive the entire world in the coming days. Let it be automotive, let it be industrial systems, let it be your toys. As you load with more and more software and electronics, it is an inevitable evil, provided if you are prepared for that. That's where the whole discussion today is actually that. What opportunity exists for it? So such a boom is happening, and we will see what kind of skills, how we assure safety and security for these devices. For that, you need to understand a clear shift that has happened in the last couple of years. Earlier days, when we manufacture a car, people say, I follow excellent quality system. Quality is nothing but doing anything first time itself in the right way. You don't have to rework it. That's what you call it about quality. You heard of ISO 9001. In automotive, you have something called SPICE. Nothing but it's quality models. You also hear about, Six Sigma models, where parts per million people say, okay, one of the cars out of 1 million could have a quality defect. That's acceptable level of quality defect. Now, from that, today we are living in a world with the software and the electronics loaded into a car. That concept approach alone doesn't work, because the failure of your ECUs in the car, your braking unit or your airbags, it throws up a different pattern. It doesn't fail like your traditional mechanical system. So that is where a concept called a risk-based approach came into existence. And the risk-based approach is nothing but systems engineering principle. It is derived from the systems engineering principle. Now, you might ask me, what does it mean for me? And my recommendation to each engineer today is, if you are an engineer, you should be a systems person. You should not think in terms of cut and paste. Okay, I learned the language. I'm an engineer. No, this is where actually we engineers go wrong. In modern world, people, particularly in Indian context, people learn one language and they say, I'm an engineer. So if you are going to engineering college, make sure that you think big. You think from a systems perspective, where you start looking at in a car, like your braking unit. You take an example in an aircraft. If the landing gear fails, if the flight control fails, as good as the aircraft crashes. We call it catastrophic accidents. Right? In a car, your entertainment system fails. In aircraft, the entertainment system fails. It doesn't matter. So depending upon the impact of the failure, the risk assessment is done. In aerospace, we call it a 5-level assessment. In automotive, we call it a 4-level assessment. We call it ASILs, Automotive Safety Integrity Level. ASIL 1, 2, 3, 4 means ASIL D, A, B, C, D. That's what we call it. ASIL A, B, C, D. In automotive, in aerospace, we call the 5-level A, B, C, D. So that is a big exercise people do in terms of making sure that a system is safe. Right? Now, coming back to this exercise, it is a systems engineering principle. You don't have to worry too much about it, but just make sure that, if you are an engineer, just Google and find out, what do you mean by systems engineering? Any subject, if you are an electronics engineer also, electrical engineer also, computer science person also, even if you are a mechanical engineer also, go to Google, find out what is systems engineering. With that approach, let me take you to the world of standards. You have a couple of bulbs here, right? What is common, what is standardized in these devices? Any wild guess? It is the interface, right? Imagine all these bulbs are having different interfaces. What would have happened, right? Whenever your bulb fuses, you will be running around to find the fitment. Now, with this standard interface, you can go to any shop and say, I have this interface, give me a bulb. Any brand, doesn't matter. So that is the world of standards. With standard, you can still be competitive. You can add, you look at these bulbs. Each are having on a different design, right? It is a luminous intensities could be different. You still can compete, having following some standards. So when you come to safety security world, you still can compete each other by following standards. So some people say, oh, you are not allowing me to innovate in my car because so much of safety standards you're putting. No, I differ with that. Having safety standards gives an assurance that people don't die when there's an accident. So that is where when you say a safety critical system is a system that is designed for the purpose that if there's an accident, people don't die, which we all need it, right? It is for me, it is for you, each one of you. Whether you become a safety engineer doesn't matter, but tomorrow when you're buying a product, you want to buy a safe product, right? So these are some of the standards most widely used. Aerospace follows a standard called DO 178B from a software perspective. Industrial follow, which is the mother of all safety standards in all other domains. We call it IEC 61508. Don't worry too much about it. It is also a 4-level assurance standard. All these standards listed under the railway, nuclear, automotive, medical, all of them are a 4-level approach. Means you categorize your subsystems into 4 levels, starting from the highest could be your brake unit in a car, right? The brake fails, okay, it is guaranteed that there will be an accident, you could die. So railway has got a similar approach. Don't worry too much about that aspect. You can learn a little bit step by step as you go forward. Now, one of the fundamental difference which you will see from an IT industry and here is in IT, what happens is you see a lot of technology talks happens and suddenly the technology and the skills what you learn overnight disappears. In this field, safety engineering is a fundamental engineering principle. It never dies. It never dies. So whatever engineering principles you learn in this area, particularly safety or security engineering areas, it is a lifetime skills. You work 20 years, you work 30 years, you're still in great in demand in the industry. Unlike in the IT industry, where every time you are forced to learn something new technology, here also new technologies will come. Nothing is not a stagnant area. You will still deal with new technologies, but the fundamental experience what you gain will take you for years. Just 2 use cases. This is from the aerospace industry, where they follow the system safety assessment process. As I told you, the systems engineering process, they call it the ARP, Aerospace Recommended Practice. And then you come down, bottom line, you take 2 areas, right? One side is the electronics part, followed in the aerospace industry. Right side is the software part. In software also, you have onboard software running in a aircraft as well as ground traffic control. Both need to be safe. So then there are other standards for model engineering, model-based engineering, tool qualification, formal methods, and so many other things. Do not worry too much about it. So I just give you an example that, when you enter into an aerospace industry, this is what you're going to enter into. It is a lifelong learning exercise. Every step you go further, you're moving up the ladder. And you are not going to waste even an year in this game, because whatever you study next is as a build up on what you studied first, right? Same way so it is when you go to the next level. This is another example from the automotive industry. There is a standard called ISO 26262. I spoke to you about functional safety. This is a standard framework used for an automotive electronics development today. Don't worry too much about it. You look at the part 6. Part 6 of this standard talks about software. Okay, part 11 talk about semiconductor. If you're going to use semiconductors in your car, you're supposed to follow this. If you're going to launch a bike, you need to follow part 12. We have customers in 2-wheeler segment as well as in 4-wheeler segment. They follow this as a Bible. And you won't believe, from next year, if you want to sell any automotive electronic part in Europe, they need to follow a security standard called WP29. Without security certification, they won't allow you to sell anything in Europe. And slowly you will see these standards becoming a Bible across the globe. So when I say Bible, no deviation will be allowed. So if you know C programming, if you know a little bit of embedded programming, what you need to go is, next is start thinking like a systems person. When you look at the car, you should look at what is there inside the car, each are the subsystems, how they are talking to each other. That's where your engineering mind comes in. When you see a medical device, you should look at what is the overall medical device running. Please don't look at, okay, I did a GUI. That is what the typical application developers do, right? Now, believe me, guys, these GUI developers, they come and go. But in our field, whatever you develop, it will last forever. You will have still more new technologies like, AI, a lot of things will be coming into this area. You still be dealing with them, but then the fundamental principles remain the same. Now coming back to why when we look at today in the industry, this is the issue which we are facing. There are a lot of opportunities, but there is a skill gap. Now, what is the need of the market? When I deal with my customers, they are looking for full stack engineers, an engineer who understand from an overall perspective, right? If you have a product development mindset from the beginning to end, please don't think that, I am an engineer, let me look at only basic coding or let me look at only testing. No, if you are a tester also, you should know how the overall medical device works, how an overall, braking unit works. This is an engineering mind, and a typical arts college student can't learn this. And that's what I strongly recommend to get into this area. The reason is you don't get a competition from a non-engineer. Rest be assured. Whereas in the other areas, you go to an IT sector, it is cyclical, highly cyclical in nature. Demand goes ups and down, and anybody can. And the next thing is, you work 15 years, 20 years, you still face a challenge from a fresher. That very next day, a fresher comes and replaces you. This is an area, every year you add your expertise. In a company like LDI, you will find people working in 50s, 60s, 70s because they are in great demand because they come with that kind of experience in dealing with a reactor or an aircraft or a missile or whatever it could be. It's a lifelong learning experience. So this is my summary that we work with the ecosystem to make sure that the right skills are available in a country like in India, where we work. That's where actually our association with skilling came into picture. We worked with skilling to develop a verification course. In terms of, you might ask, why verification? Very simple. Out of jobs which are available today in the market, verification jobs are the most commonly in demand, which is especially in a country like India. A lot of testing jobs are getting outsourced to India because most of the companies make sure that testing is not done by the designer and developer. A third party person is better worth doing the testing. So with this, let me conclude. I'm sure you might have questions. You could raise your questions.
Thanks, Shinto. Thanks for your very insightful presentation. I'll look for questions from the participants. So members, if you have any questions, please post it on the chat so that I can take up your questions on behalf of you. So before that, I have some questions from my experience from my end. Shinto, one thing that we have observed from a lot of our customers are our students as a mindset that they feel that understanding about verification validation and going for a job role that's associated with verification validation is slightly inferior than taking up a development role. So what's your thought on that?
Okay. If for that, actually, I should take you to organizations like ISRO. Okay. ISRO is my customer. You won't believe the verification team has got an upper hand on the design development team because they are the ones who finally clears the product. Now, from a practical perspective also, I'm not against development job. Development is good. Nothing wrong with the development job. If you get a chance, please take it. There's nothing, you should not look at it that. But if you look at the safety market, more than 50% of the time, I mean, if you take a civil aviation, sometimes even 60% of the time of that entire aircraft development life cycle is spent on testing. So more people are required in testing than in the development. Most of the development the job also it is getting automated. It is just getting automated. They put the whole thing into a model based framework, and the code is generated. But still, it needs to be tested thoroughly and the host level at the target level, and the certification exercise is a very lengthy process. Second, this is an area where you need more engineering expertise. Without engineering background, without what I told you, the systems engineering principles, you are not going to survive in this area. So, by getting into this area, from a job opportunity point of view, also as I told you, this sector has got more job openings than the development job from an Indian perspective. Most of the time, the development or design they do it elsewhere in the world. The testing is the one they want somebody else to look at. Finding fault in others' job is easy, right? Doing it might be difficult, but That is a perspective. But there are some sectors like aerospace, it's mandatory that, you need to have a third party verification to be done. So there are a lot more avenues for growth, and being an engineer is a lifelong learning. So it is not a bad job. It is only the perception in India among some sector of people. Those who are working in this field, you can ask them that, they enjoy it. It's a lifelong learning. The only thing is, don't go the manual test way. That is boring. Today, you don't have to do the manual testing. You can use powerful tools like LDRA and then use your expertise. Your expertise, nobody can replace. You need to build your expertise, then use tools like automate certain activities. Don't go behind the manual testing. It is boring.
Thanks, Shikram. So here is the next question that's coming. And I think you having a chance to work with very close with academia and being part of many board of studies. So what exactly you feel as a current gap in the current academia, especially in the core domain, and how well they are able to use and like the other day they have understood that in this era digital skills play a vital role. So where do you see that gap?
Okay, see, it is like this. Everybody knows the problem. Okay, industry people also tell, oh, academia is not doing things. You ask academic people, they say industry people are not helping us. It's a chicken or egg situation always. And I have been both sides. I've been seeing this game from both sides, and I always say work closely is the solution. I personally have spent, we have done so many faculty development programs. But however, there is always this issue that, end of the day, it doesn't work for various reasons. I still don't know what made in Indian context it doesn't work, because this blame game, people are very good in finding fault and blaming each other, and very few people are interested in fixing this issue. So the only way forward is one is creating a framework which is something in between. That's where actually a skilling kind of platform I found it very relevant. That you are somewhere in the middle where the benefits of both sides can be taken and bring some content. The other option for academia is actually there's a concept called professor of practice, where a lot of people, industry people, can go back to academia and teach. So that's a combination of model will work better for us. But the current model is not sustainable. It has to change. So people like me, I keep fighting that, it's not the question of blaming. We need to work together with the academia. And from an industry perspective, it is the other way. I have customers who says, I'm ready to invest on your tools, but where are the engineers? I don't have engineers to work on. So why we are there in this business, in spending, I personally drive this itself is, I see a direct growth path of my business when I produce skills in this country. And India is the land of skills. And if you win this battle in India, we win the world, because most of the work is happening in this country. So if I produce the right skills in this country and my business grows in this country, my parent company win the world. So I get all the support from my parent organization. So it works two ways actually. My customers are happy. We help the youth to find the jobs. End of the day, it's a win-win game for all, right? As a company like us also, we can't grow ourselves. We have to grow with the ecosystem, find the our portion of the success along with others.
Thanks.
So friends, actually, I suggest you could park your questions either in the chat box, or you can straight away put these questions to Jagan.
So I think Shinto and Jagan, we received like a couple of questions in my inbox. So one is, question asked by Abhik. So to develop a car or, bikes software, sometimes we see they fail, just as the traction control system fails and accident occurs. So what might be the reason, or what might be the developer's fault?
Okay, you asked the right question. Normally what happens in this field is you can't blame the developers, because in automotive industry, safety was never a concern. From a software angle, safety was not a concern. Normally they used to think that bike safety, normally the tire, brake system, which are mechanical things. Car, again, brake, mechanical brakes. This was the mindset. Even if some software was added in the car, yeah, it works. Yeah, functionally, there's no issues. That was the mindset which was predominantly there in the automotive industry. Suddenly, when the content of software started increasing, people did not change that mindset. So they continued it. Many of them even downloaded some freeware software. Open source, softwares also were downloaded. I don't want to tell, there are so many examples right now in Indian context itself. The open source, when they loaded into their cars and bikes, what happened? So it's okay you use open source, but then we call it software with unknown pedigree. If you're using something with unknown pedigree, make sure that you do test it thoroughly for safety. So ideally, you should do it by design. By design, the software should be safe. By development, it should be safe. That means use the right development environment to develop it. The safe environment to develop it means your OS should be safe. Your compiler should be safe to use it. Your testing should be for safety practices. So safety, I told it comes by design. It doesn't come by accident. So by downloading some, freeware coming from somewhere and loading into the car, it is working fine. But on the way, it fails and create accidents. People die. This is what has happened in most of the places. You look at the battery fires happening, right? Batteries were never tested properly for safety. This is where actually people made noise. That it started moving. Suddenly you see everywhere fire happening. It was never tested for safety. So when you know that you're playing with fire, please test it thoroughly. Design it. Actually start from the design. From a design development. So I spoke about ISO 262. I spoke about ARP framework. They're all nothing but design framework. It starts with the design. It starts with the development. It starts with the testing. So it is not an easy game. So if anybody thinks that it is an area where I can learn a GUI kind of thing and get away with this sector, sorry, I strongly recommend this is not your area. You should go back to our IT, do some cut and paste job, be happy with that. But if you think that I want to be an engineer, I want to challenge my skills, where I can save my fellow citizens from dying, and not only dying, it's an evergreen career, as I told you, it's an evergreen career. It doesn't die as a career. Safety is something, you will never find. As far as this world is there, it will be there. Yeah, maybe we'll go to the next.
Great. Thanks a lot, Shinto, for answering that question. So next question is asked by Vardha. So sir, I am a mechanical engineer. Can I do my postgraduate as safety engineer? But which field will be better for me?
Okay. Now, I would answer this question. Recently, I was in a discussion with my own college where I did my engineering. They started a safety MTech program under mechanical engineering. And the people asked, why only in mechanical? It doesn't matter. As far as you're an engineer, safety is a subject, anybody can learn. It doesn't matter. Now, safety engineering has got a wider application. It need not be in software area. It could be your overall system safety of your structures, mechanical structures, civil structures, electronics, software. It is a wide range of applications are there for a safety engineer. Now, if you want to go to a specific area after that, you need to look at the standards and methodologies used in, for example, industrial safety. Okay, process control. People who are developing lift. I work with companies like Kone in Chennai. So they develop escalators, and so there the dynamics are slightly different. So it's a step by step learning. You can't learn all these things. That's what I know. It's a lifelong learning. What is required is a plan that I want to become a safety engineer. Fine, fair enough. And in safety engineering, after doing phase 1, phase 2, phase 3, a slightly longer 10-year vision, you build it, and then you work backward. And I'm telling you, as far as you go on a fundamental engineering principle, you will not go wrong. You are not behind a concept like AI. Today, everybody is behind AI. I don't know what will happen to AI after 5-6 years. It will become like a normal thing for everybody, right? It's for everybody. So instead of that, when you go to a fundamental engineering principle, you will find it will be forever. But don't stop it there. With safety engineering, build your other skills. Even if it's your mechanical, ideally, to be frank, in India, what is lacking in our country is mechanical and electrical domain should have undergone a massive transformation by putting digital skills. Electrical, in fact, last month I was in a serious discussion with the power sector people, where I said, what is going wrong with this? Digital skills has to be put it into electrical syllabus. Mechanical also should need a lot of digital skills, because we need a mix of both at the end of the day. So my request to mechanical engineers is, even to IT guys, please don't stop it with your software skills. Look at how your software can run on an electronics hardware. That's where your systems thinking comes into picture. Please don't stop it with your software programming skills. See how you can run it on an embedded hardware. That way you become a perfect engineer. Otherwise, I call you as a cut and paste software person. I'm sorry to use that word, but then that's the reality today.
Great. Thanks again, Shinto. So couple of questions, which I'm getting in my inbox is revolving around, kind of, software to be, learned, or technology to be learned, and what kind of, industry-oriented projects we should be working on, right? In order to get the technical core jobs in the top tech giants. So, I think if Jagan can basically help, in explaining, or if he can basically give a walkthrough through our website on two programs, like one is online and offline program on embedded, that will actually help a lot of people getting their answer, like what kind of projects needs to be done, what kind of software or tools they should be learning, and where they can basically lend after doing this kind of upskilling.
Thank you, thank you. So if you see, Skilling has launched a couple of programs where one is on offline PG that we offer on embedded software development and validation for especially for EV systems, and also we have one other program that is again online equivalent of this course. So in online it's a self-paced mode, in offline it's 24-week program. So if you are an engineering embedded job aspirant where you feel that you want to start your career on embedded system, so our recommendation is you should know some of these mandatory skills, which either you are learning it by yourself or you are taking it from us. Without this, it's really difficult for someone to start into an embedded field or start their career in embedded field. So the very first mandatory skill is like you should have a very solid inclination towards writing program, and so being an embedded system, so the most preferred language is C programming. So ideally you need to know the C essentials, and basically how do you use C language for writing embedded programs. So then post that you need to have some understanding about the kind of software development process and even system development process. So in industry it's called as SDLC. So you need to know standard terms and standard workflow of different SDLC techniques that's adapted, and that is covered in our fundamentals of embedded system course. Then most industry expects the engineer to write their low level driver or having an exposure of writing low level drivers. So which means this shows that you have studied and you have practiced microcontrollers, either it 8-bit microcontroller or a 32-bit microcontroller. It could be an ARM architecture, PIC or AVR architecture. So in our program, we cover AVR and ARM, and there are very superior standard third-party hardware abstraction layer that is existing. So we also cover how to port, reuse those stacks to build your own application on top of it. So that's covered in our device drivers and serial communication course. So then we have our very important course, which is on software verification validation. So here's where we have a strategic relationship with LDRA, and LDRA is very much magnanimous to offer a unique license, especially for skilling students. So here we teach some of the basic concepts of verification validation, starting from static analysis. Why static analysis is important? How do you do static analysis? How do you find static violations, and how do you fix that with the help of tools like LDRA? And how you can generate code coverage report, how you can automate test cases. So Mr. Shinto was telling about how do you automate your test cases, how do you apply your intelligence for ensuring that the software is safe to get into a reliable system. So all those things are covered in this particular course. So then we have a course around our EV systems and C++ programming. And again, for EV related courses, we go with model-based approach. So we have a strategic relationship with MathWorks, where MathWorks is offering tool licenses for all our PG program students. And there we cover basics of model-based development with Simulink Stateflow kind of a tool. Then we have model verification technique there also. So very similar to code verification, model validation is also one of the common and very important skill that is expected in industry. So then we introduce courses on batteries, on hybrid vehicle, on E&E architecture. So this is what we offer currently as a bundle, and we offer as a 24-week long program. Hope this answers your question. So there are a lot of industry aligned projects that one can frame the requirement, implement, and they can develop a very beautiful or a very big portfolio of their resume to participate in the job interviews that's happening in today's market. We have some more questions that's coming on. I think Mr. Lucky is asking, is this a paid version? Yes, it's a paid version. I don't know what do you mean by paid version. So LDRA doesn't have some sort of trial version or some limited duration. So LDRA is actually offering a student packed version that is exclusive for the members who are taking this particular program. So same is the case with MathWorks groups. So in my personal chat, I got one question to Shinto. So that's coming from Rakesh. I'm an engineer doing my final year, interested to get into this embedded, and I'm confused to take up these job opportunities on the hardware domain or software domain.
I assume he might be an electronics engineer.
Yeah.
Otherwise, he will not get this confusion. So with that, my suggestion is, there's nothing wrong with the hardware design jobs. It's much more premium than a general embedded thing. No doubt on it. But the challenge is two aspects. One is it is very expensive, to get that skills. Second, the hardware design jobs are normally with very large firms, semiconductor companies, who goes to the Tier 1 colleges only. So if you are not from a Tier 1 college and try to spend lakhs of rupees investing on a hardware design course, probably finding a return on investment will be a challenge in terms of finding a job. So that is where actually I'm talking purely mathematics, end of the day, return on investment. So from a return on investment point of view, job guarantees will be more in the embedded space because more number of jobs are available. They don't normally care about whether you are from the IITs or NITs, or they don't bother. What they need is basically people who can develop skills and ideally basics they expect you to know. Because I work with the Tier 1 OEMs as well as the OEMs as well as the Tier 1 vendors and service providers, starting from all the service providers in India. So they expect you to come prepared with the basic skills because they don't have the time to teach you. So that is where actually we thought, why we spend all this energy with academia or even skilling kind of organization is to make sure that our clients get a pre-processed minimum skill set, so that they don't have time, because always time-bound projects, they are busy with that. So if you can make sure that some basic learning is done before even you get out of the campus, Please don't even think that, pass out, then I will learn. No, if you can, ideally, suppose you have passed out, searching for a job, that's a separate issue. But don't delay it. Normally, people postpone it. We will see it later. We will see it later. From first year onwards, I've been telling this. Now we'll see it later. For eighth semester also, I'll see it later. No, today itself, take a call that make sure that you build up your fundamental skills and prove yourself in front of an interview board that you are not like a 10-page person, you are a true engineer. So that for that, like Jagan mentioned, build up some projects. If you are in a college level, you can even think about multidisciplinary project. I mean, you can collaborate with one electrical engineer, one computer science person, and one electronics person. That makes a perfect fit for a multidisciplinary project. Many deemed universities, I can see that they're encouraging. So those are the ways you can utilize the environment and talk to people in the industry. Go to LinkedIn, find the right set of people whom you can reach out. So please don't think that people will get everything in a plate. And I've seen that just by joining a course in skilling also, nothing is going to happen unless you put in your effort, burn midnight oil like anything, and show that having a CV also no use. Whatever you claim in the CV you should have done it. Most of the time, you have a lot of CVs available. People download it, cut and paste, attend the interview. No, don't do that. Whatever things you've done, put it and try to defend it. And nobody expects you to have a rocket science knowledge also. What they need is basically walk the talk. Means you should be sincere in what you are telling that you should have done. I've done 5 projects only. Fine, I have done only 3. It's okay. But it should have been done by you. It should not be copied from somebody else. And if you think interview boards are, jokers or they are fools, we can fool them. No. They are smart enough. They have seen people like you thousands. Yeah. Any other questions?
Thanks, Shinto. So one last question from my side. So you have worked very closely with many customers in India. So from your observation, what is the big challenge that they are facing?
Okay, so they face actually 2 challenges. One is you take any industry, take automotive as a classic example. Every industry having more or less same problem. Traditionally, they were more on a mechanical oriented thinking, and they have a lot of such employees, hundreds and thousands of employees with that background. Now, suddenly, it's not suddenly, this trend started years back. Probably they didn't act on time, right? Now there is a pressure on them to act, where most of these skills are probably redundant or not worth. So they have a challenge. They are sincere employees. They don't want to throw them out. So they are working on reskilling them, upskilling them to new areas, because they understand the automotive domain very well. So that is one challenge. Upskilling and reskilling the existing employees. Where my recommendation is they need to spend little more time to learn the fundamentals. Don't wait for the company to teach all these things. Outside the company, one should be able to, because some of these companies, suddenly what they will do is, oh, anyway, these guys don't know anything. I'll replace them. They will find a bunch of freshers and they take over that. Now, with regard to freshers, the syllabuses right now don't address this. So they have projects coming in, but then they don't know what to do with these freshers coming in. Because you all know that the mindset of current generation, I don't blame any one of you. Most of you might be freshers. But unfortunately, my kids are also in the same age group. Most of these kids are joining with the mindset, let me get the job and jump. So because of this attitude, many companies are very reluctant to train them also. So, which is a very difficult situation. Ideally, you better make sure own your career, learn things on yourself, rather than going to a company and company expecting you to teach everything. That era is gone. So I run career planning workshop because of passion in this area. In fact, I run a YouTube channel also on the same. I discuss similar issues. I always say our career is our career. Company has nothing to do with this. Company will have company's problems, company's business plan. If we don't look after our career, we are redundant in the industry. So make sure that you have a plan, keep updating your skills, and gone are the days of long courses, 5-year course, 7-year course, people taking PhDs. I warn you guys, Please don't go in that route, because what is required in today in the industry is right incremental skills. Today, there is a market demand for a particular skill, you have that. Tomorrow, another skill comes. So, upskilling, keep upskilling every now and then, and with an attitude of learning for lifetime learning. That's the only way we can be relevant in today's world. You think I got an engineering degree, that degree is going to take me for lifetime? Sorry, you are digging your grave. Day one itself. And many of us I'm in my 50s. My challenge is actually how to cope up with the fresher who is coming in, who comes with, n number of questions. This is a challenge we seniors face. So for us also, staying relevant, the only solution is keep learning, keep learning, keep learning. That is where actually I see the future of edutech as a business coming in. More and more universities, I conduct faculty development programs. I keep telling them, keep a online version of your university. Otherwise, you will die in the near future, because more and more students probably would go in that route. The bricks and mortar way of our academia probably needs a reboot. It will happen, in the coming years.
Great. So thanks, Shinto. I think two more questions came. So one question is like asked by Anmol. So I am an electronic engineer, but now I am currently working for non-tech organization. So can you suggest for move in my domain field?
I assume that you are not right now not in the technical area. Correct.
Yes.
Okay, fine. Nothing to worry. After all, you are an engineer. Now, I go back to my previous thing. Who defines our future? It's we. Me and you decides our future, right? So if you have made up your mind that I want to go back to my core skills, you need to make up your mind, put in a plan, do a SWOT analysis. What are your strengths? What are your weak areas? What are the opportunities you see? What are the threat areas for you? Work on your weak areas. You will find that some of the skills you might have forgotten everything, right? So nothing to worry. We human beings, we forget things. That's okay. But as far as you have that spirit of learning, uh, basic programming is something you can start off. Take a C course uh, to start with. Brush up your brain. Sometimes brain has got a problem that if you don't use it properly, start getting rustic. Virtually, it gets rustic. So shake your head properly. Make sure that start reading something, and intellectually you activate your brain. It takes some time, maybe a couple of weeks. Mentally, you prepare. You might get some frustration, doesn't matter. I strongly recommend whenever you start this kind of journey, mental health is the key thing. So start some yoga, meditation. All these things will help you to stay focused, because you are taking a new journey in your life, right? So mentally prepare, sharpen your brain, do some exercises for your brain, reading habits. Uh, Start off in a small way and keep telling your mind every day, I will make it, I will make it. Because what you tell your mind will respond. Don't listen to other fellows who tells you, boss, you will never make it. This world is like that only. People will be telling you not to do, not to do, not to do. You will fail, you will fail, you will fail. And you look at anywhere, even if you look at the TV channel also, TV channels also show you only negativity only. Nobody teaches you, tells you positive things. So you need to find out one or two positive buddies. Talk to those people who can motivate you. Avoid those negative elements till you prove, because you will go back and show them, man, I've done it. Till then, don't talk to this negative element. Find some positive buddies. Talk to some industry people. There are a lot of content available either in Skilling or in YouTube channels. How you can sharpen your skills. I'm of the opinion that age is it's just a number today. It's all about what matters your attitude to learn. Nothing stops you from learning. I wish you all the best. I'm sure you will probably recollect these words when you become successful. Thank you. Thank you.
Mehul, do you have
Yeah.
any more questions?
I think no. I think we are done with the questions. Yeah, I think we are done with the questions. Yes.
Good. First of all, I thank your skilling team for inviting for this program. I mean, the subject is very close to my heart because, as I told you, right, everybody talks negative. That's the world which we are in. And that negative thinking and negative talks is not going to take us anywhere. Whether we are in academia or industry, keep telling everybody a positive message and making sure that, end of the day, people are successful in their life. That motivates all of us. That's why I'm here. I really appreciate you guys for hosting this program and for the attendees also. I think if there are further queries, reach out to them or me. Me and Jagan, we are very active in LinkedIn. You can catch us.
Yeah. Thanks, Shinto. Thanks for your time. It's great to have you here.
Thank you so much, Shinto and Jagan, for the wonderful session, and hope everyone, enjoyed.